pop into the folder called By the Histogram. And let's say, for example, you've got a photo studio and a client comes in with a photograph that's been sitting on the piano for the last 20 years in the sunshine. And what happens to pictures when they're exposed to light? The sun sucks up the color. Yes. Well, it fades the color. I guess if it sucked up the color, you'd actually see it leaving back up to the sun. But yeah, it fades out the dyes that are in the paper. And if you were to scan that, you'll be able to see that damage in the histograms. In fact, once you call up this image, call it up in Photoshop and take a look at its histograms. Fast way to get to the histograms, if you go into the window menu and histogram, it'll actually show you a full color histogram. When you're in things like levels or curves, it gives you a grayscale representation of what the histogram looks like. Here, it looks more like the histogram that you see in Adobe Camera Raw. You can see each color channel. And looking at this, what sort of color cast would you expect this image to have? What color does it seem to be dominant in? Either by looking at the image or the histogram. Yeah, look at that. Closer to white. Here's 0. Here's 255. That red is clearly dominant. And sure enough, there's a strong red cast in it. So would it be the middle slider? Or, well, let's take a look at each color channel. The damage in this case, we're not really going to see it if we look at this overlay. But if we go to expanded view and all channels, well, let's take a look here. Here's the histogram for each of the individual color channels. And the green channel starts down here at black, works its way all the way up to white. So a nice good tonal range in the green channel. The blue channel down here starts at black, works its way up fairly bright, okay. But the green channel, look at what's happening here. It's almost like the dyes have just been faded right out of the image, and they're working their way towards 255, which would be white, which would be nothing. So what are we going to do about this flat spot here? Well, let's throw on an adjustment layer. Again, we want to keep this non-destructive. Well, as non-destructive as possible. I mean, this image has already been fairly heavily damaged. But I'm going to throw on an adjustment layer, and I'll throw on a levels here. And you'll notice in the grayscale RGB histogram here, we can't really see what the problem is. But again, if we go in channel by channel, the green channel looks fine, blue channel looks fine, red channel, there's no pure black, it's all washed out. And if we look at those channels individually, there's the green channel, nice deep blacks, nice bright whites. There's the blue channel, nice deep blacks, relatively good whites. Red, oh, where there's supposed to be black information, there's nothing going on in there. All right. Well, let's hop back to that layers panel. So back to the RGB there. And I'm going to call it this levels again. And if I go to this red channel, BHFS, big honkin' flat spot. How could I close that up? Well, if this was that elastic string, here's 0, here's 255, if I could grab this bead and stretch the elastic, there's nothing here anyway, so it's not like I'd be losing any information. There would become some gaps in between. If I said, okay, well, you know what, there's no beads on the string down, I'll just grab this and stretch it down, you'll get some gaps in between. So technically that is damage. We still consider this to be non-destructive because it's not doing any more damage than was already there to begin with. So really I would have to kind of take my endpoint and stretch it down this way. The beads would slide their way down, but I can't pull this outside of this window. But if I grab this and pull it up to the right, I can't pull this out to stretch these beads down, but I can reassign where 0 is. I can say, okay, well, black will become whatever that bead was. And if I close up that gap, look at what happens to the image. There's a nice color correction in that image. So give that a try on the other two in there. And this is just basically eyeballing it. We're not necessarily looking for any numbers per se. We're just looking at the histogram and assessing what the damage was. So I'm going to call up a levels for this. I'm going to go through channel by channel. There's no clear problem in the RGB, but when we get to the red channel, oh, no clear problem. Let's go to the green. Aha! Big honkin' flat spot. Pull that up. And you'll notice a very strong blue cast in the shadows. Let's pop into that blue channel, and let's clear that up. So in this case, it was all the end points. Just grab that black point and slide it up to close up that gap. Give it a try on the third image as well. See what you can come up with. Now in this case, I've pulled up the black point in the red. I've pulled up the black point in the green. There doesn't seem to be a flat spot on the left there on the blue, and yet the clouds are still kind of coming out a urine-y sort of color, aren't they? That's white. Ah, flat spot up here. Okay, so if this channel, there's no pure whites, we can reassign white to whatever the brightest pixel is. So I mean, that's pretty straightforward. And really, if you use the auto button, that's essentially what it's doing. It's basically looking at each channel and saying, well, there's a big flat spot there, we'll pull that down. There's a big flat spot on that side, we'll pull that up. That's basically what the auto button is doing on the levels there. Is that always right? Just grabbing the endpoints and pulling them in? Not necessarily. I mean, like we saw when we looked at the contrast, there was that tree on the, the snowy field there that had a really kind of washed out sort of look. If we just clicked auto on that, it would take that, close up the gap, and fix, so whatever the brightest pixel was would become white, whatever the darkest pixel was would become black. But that wasn't right for that image. It was a foggy day. If you're taking a photograph of the woods and there's like strong fog, it's meant to be kind of grayish. So like we saw before, it's not always the best thing to pull these in, but if you know what happened to the image, in this case, it's been sitting on that piano, the ultraviolet, the UV from the sun has been fading it out, basically just destroying all those dyes in the paper. You can see the gap, pull it in. Scanning software will often have an auto color correction as well. Basically, it'll do the same thing. When it scans it in, it'll go, oh, look at this, there's a big flat spot here. We'll pull that down before it saves it up. Sometimes you might find, I've corrected, everything's stretched out, but there's still a color cast to that image. That would suggest that one of these channels wasn't clipping information, it was either too bright or too dark. What color do you see in there? And a lot of people go, red. Sometimes it can be hard to figure out what sort of color you're dealing with. Blue and cyan can often be very difficult to figure out. Yellow and green are surprisingly sometimes confused. If you've got an image of like a field and you think, oh, it's too green, it can actually be yellow. In this case, a lot of people look at it and go, oh, it's too red. Look at that, look how red he looks in the face. And to find out if it's red, we could try to correct for red. If we call in our levels there and we look at our red channel, starts at black, goes up to white. Okay, all right. We can tell, see how this left side here kind of makes its way down, down. We know that we've got good tonality in the shadows there. Sometimes if you see a big flat spot, it suggests that you're clipping shadow information. But in this case, I think we're okay. The green channel. Oh, well, it was the green. We thought it was magenta cast in the image, which means the green channel had problems, and yet it starts down here at 0 and ends up here at white, still has good tonality through there. And the blue channel also still has good tonality. Well, let's say it was a red problem. To fix it, we would have to subtract red. So if we pull this to the right, we're subtracting red, but it's not really correcting the color of the image, isn't it? He's getting kind of a coolish, almost a cyanish sort of tone. And cyan is the opposite of red. So clearly it wasn't a red problem. Let's go to that green channel. And if we pull to the right, we're subtracting green, which, whoa, adds more magenta to it. But if we go to the left, we're adding green, which subtracts magenta. And that looks like a much more natural color correction. So if you're not sure what the color cast is, just call up some levels and play around with it. So if you found there's no flat spots on either side, all the histograms look good, it means one of the channels is too bright. And in this case, it was the green channel that had been too dark. It was deficient in green. So by pulling this to the left, we added some green, image fixed.